Once you create your object model, then you can query a SQL Server database using LINQ to SQL. And the beautiful thing about it is that you're going to use the familiar LINQ syntax. Again, that's one of the great things about LINQ. The actual syntax for querying is pretty much the same whether you're doing LINQ to SQL or LINQ to XML or LINQ to entities, etc. So how does it work? Well, LINQ to SQL is going to translate your LINQ query into SQL statements and then pass them to the SQL Server ADO.NET provider. And that provider then sends your SQL statements to the SQL Server for processing. The ADO.NET provider returns the query results as a data reader, which is an ADO.NET class, and then LINQ to SQL translates those results into an iQueryable collection of anonymous types. So you write a LINQ to SQL query, that gets translated into a SQL statement that the SQL Server understands, sent to the SQL Server, and the results get translated into an iQueryable collection. If LINQ to SQL is translating your queries into SQL statements, you're probably going to want to see those SQL statements. And there are a number of ways you can do this. You can use the log property of the data context class. You can set it to console.out, and that will display your SQL statements in the output window. You can also use any instance of the text writer class. So you could literally log these. You might, in an application, want to log the SQL statements and just write them out into a text file and look at them later. You can use query.toString. So where query represents your LINQ to SQL query, you can actually use toString to display the SQL statement. You can also use datacontext.getCommand. What that does is it returns an instance of the ADO.NET DB command class. And your SQL statement is then contained in the command text property of that class. Or you can use the SQL Server Query Visualizer. That gives you the ability to look at the generated SQL at debug time. Now, this doesn't literally ship with Visual Studio, but it's a free web download and very easy to set up. And then the fifth thing we're going to talk about and see how to use is the SQL Server Profiler. And that ships with SQL Server, and that gives you the ability to see the SQL statements that are sent to the SQL Server. Now, this doesn't actually ship with SQL Server Express, although we're going to use it to see the queries that are sent to SQL Express. So you can use any of these techniques, and we're going to use them all, to see the generated SQL statements. I said earlier that one of the benefits of using LINQ to SQL is that you use the familiar LINQ syntax. And so for the rest of this section, I'm going to assume that you have some familiarity and experience with LINQ, but that you'll also benefit from seeing a lot of queries using LINQ to SQL to retrieve data from the SQL Server database. So we're going to start off with fairly simple queries and then work our way up. So when you write a simple query, you can retrieve one or more columns from a table. You know that the from clause is going to be used to identify the table in the database. You can use where to limit the results, select to identify the columns that you want returned, and you can use an order by to sort. So in this example, we're going to retrieve some information from the customers table. We'll create a query variable. That represents our query. From cust in nwin datacontext.customers, that tells us we're working with information in the customers table. We saw in the previous section when we created our object model that the data context has a property for each of the tables we dragged in. And here, nwin data context is our data context pointing to the Northwind database. And one of the properties on that is customers. This query says go into the customers table and bring back customers where the country is equal to the USA. We want the results ordered by region and city, and then we just want to bring back the company name, the city, and the region. We're going to see examples using scalar functions. What's a scalar function? Well, a scalar function operates on a single value and returns a single value. And you can use scalar functions to filter your data or to transform your data. So here we have two queries. The first will do a filter, the second will do a transform. Query 1 goes into the products table, and we're going to bring back product names where the product name starts with A. So starts with is a .NET Framework method on the string class. It's actually an extension method of the string class. The product name is a string. We want all of the product names that start with the letter A. And then we'll bring back product name, and we'll rename it prod name. In the second query, we'll go into the products table. We're going to bring back all the product names, but we're going to convert them to uppercase. We're going to see examples of using aggregate functions, and an aggregate function operates on a collection of values and returns a single value that summarizes that collection. So a typical use of aggregate functions will be to return summary information, so count, min, max, average, etc. So here I just want to know how many orders were placed. So I'll create a query, and I'll go into the orders table, and I'm going to bring back order, and I'm going to use the count function to tell me the number of orders that are returned. So let's go see a demo of some additional simple queries and then queries that use scalar functions and aggregate functions. I have the LINQ to SQL demo project open, and this project contains an object model based on the Northwind database and then a number of queries. Let's take a quick look at the object model. It's going to wind up being pretty much the same as the one we built in the previous section. We have customers, orders, order details, products, and categories. Okay, so let's run this. And the first thing we'll do is look at some simple queries. So I'll press A. All right. Before we run any query, the first thing we need to do is get a new instance of the Northwind data context, which is our object model. And so that's going to be the variable nwind data context. And once we have the data context, then we can write queries. We can also see the SQL statements. So I'm going to set the log property of the data context to console.out, and that will display the SQL statement that LINQ to SQL generates in the console window. Because remember, what happens is LINQ to SQL takes the LINQ query, generates a SQL statement that SQL Server will understand, that gets sent to the SQL Server, then the results come back. So the first query we want to do is go into the customers table, bring back the company name for customers in the US. So we create USA customers as our query variable from customer in nwinDataContext.customers, where customer.country equals USA, select customer.company name. And then when we execute that and define the query, remember we haven't actually executed the query itself, we've just defined the query. If I come out into the console window, we don't see a generated SQL statement yet because the query hasn't been sent to the SQL Server. All we've done is define it. Now we'll display a header, and now when it's time to start retrieving information, now the query gets sent to the SQL Server, and this is the query. So this is deferred execution. You define your query, but the query doesn't get sent until you actually try to display the results. So here's the generated SQL statement. This is what SQL Server gets. Select company name from customers where country equals USA. Now USA customers is our iQueryable collection of customers. And for each customer, we're going to display the company name. So I'll run the rest of this. And here are the companies in the US. Okay, let's look at the next example. Again, before we query, we're going to create a new instance of Northwind data context. And the data context is actually designed to be created all the time. So the advice from Microsoft is that you should feel free to create a new data context as often as you need. So in every one of our examples, we're going to fire up a new instance of Northwind data context. And here, our query is go into the customers table, and for customers in the US, bring back the company name, the city, and the region, and order this by region and then by city. And then what we're going to do is we're going to write out USA customers. And you can see that USA customers is a SQL statement. And we're going to use the toString to write that out to the console window. So this is the SQL statement that LINQ to SQL generates. Select company name, city, region from customers where country equals a parameter, order by region and city. Then we'll loop through each customer, and we'll display the company name, the city, and the region. There they are. Okay, next up, we want to see cities in Spain that have customers. So we'll create a new instance of Northwind data context. And now here's our query. Go into the customers table, and for any customer where the country is Spain, bring back the city. But I only want to see each city once, so I'm going to use the distinct method here and just bring back a list of cities. And then to see the actual command, I can use the getCommand method of the data context and pass my query. That returns an instance of the dbCommand class. And the dbCommand class has a command text property, which is going to contain my SQL query. So here's the query that gets sent to SQL Server. Then we'll just list each of the cities in Spain where we have customers. And the final way we're going to look at queries is by using the SQL Server Profiler. And this doesn't ship with SQL Server Express, it ships with SQL Server, but you can use it to look at the statements that are sent to any instance of SQL Server. So I'm going to create a new trace based on SQL Express. I'm going to connect to my SQL Express database and run a trace. And then what I'm going to see here is all of the statements that are sent to SQL Server. So now I'll come back into my code, run the next query, which retrieves company name, city, and region for customers in the US. Here they are. And I'll go into the SQL Server Profiler, and here's the SQL statement. Select company name, city, region from customers where country equals parameter. Here's the parameter ordered by. Let's run the next example. I'll just go through this. Cities in Spain with customers, come back into the profiler, and here's my select distinct city from customers where country equals Spain. So you have your choice of how you want to see the statements. We can display them to the console window. We can use the SQL Profiler. You can look at them in debugging mode. You have a number of options. Okay, let's look at scalar functions now. Come back in here. And our query is go into the products table and bring back the product name for products whose product name starts with an A. So the query from product in Northwind data context.products, where product.productName starts with an A, and then just bring back the product name and rename it prod name. So now we'll loop through the results, and for each prod, we will display the product name. Let's run these. Here are the products that start with A. Again, we can come into the SQL Profiler, and here's the SQL statement. Okay, our next scalar function example is going to bring back abbreviations. So I want to go into the categories table, bring back the category name, and then bring back the first 3 letters of the category name converted to uppercase. And then we'll display category name and abbreviation, like that. Here's the SQL statement. Select category name as name, upper, substring. So the substring and the 2 upper convert quite nicely into Transact SQL, which is the language that SQL Server speaks. Okay, now we want to retrieve customers where the contact name contains Carlos. We know we have a customer where the contact is Carlos, but we don't necessarily remember which Carlos and which customer it is. So I want to bring back all customers where the contact name contains Carlos. This will bring me back Carlos. This will bring me back Juan Carlos. I just know this guy has Carlos in his name. Okay, define that query, run the results, and here are the Carloses. Again, we can look in the SQL Server Profiler, and this uses the transact SQL LINQ, where contact name is like, and then because we're using contains, we have the wildcard, which is the %, Carlos, and then a % after. So any contact name that has Carlos in it will be returned. Let's look at aggregates now. And first we want to know the total number of orders. From the orders table, bring back orders, and then give me the count. So the query is actually an integer, and it's the count of orders. So I can see there were 830 total orders. And I can see that in the SQL statement, I'm just bringing back the count. So I'm not actually bringing back all of the data from the orders table. I'm just bringing back a single number that tells me how many orders there are. Okay, in our next example, I want to get some information on product 7. I want to know the number of orders, the total value of orders, the average value of orders, the highest valued order, and the lowest valued order. So my first query is to bring back a count from the order details table where the product ID is 7. Then I'm going to bring back the total value. So from the details table, I'm going to bring back unit price times quantity for each row where the product ID is 7, and then I'm going to sum that. In the next query, I'm going to average unit price times quantity. Then I'm going to bring back the max and the min, and then display this summary information. So for product 7, I can see the number of times it was ordered, the total value of orders, the average, the largest, and the smallest. Now if I go into SQL Server, notice that there are a number of queries that got sent. First, I sent a query to get the count for product 7, then another query to get the sum, then another query to get the average, one to get the max, one to get the min. So I actually sent 5 queries to SQL Server for this. So what you've seen in this demo are some fairly simple LINQ to SQL queries. We looked at simple queries, we looked at using scalar and aggregate functions. It's the familiar LINQ syntax, working against our object model that's based on the Northwind database, and we saw a number of ways that you can look at the generated SQL statement. In our object model, we have a number of related tables. Customers is related to orders, orders is related to order detail is related to product, products related to category. Pretty much all of the tables are related. And we'll want to do a bunch of querying where we're retrieving information from more than one table. Now, LINQ to SQL supports querying from related tables using the join clause. And if you've been querying SQL Server databases for a while, you're familiar with join. So for example, you join customers to orders where customer.customerID equals order.customerID. And that's pretty much the standard way we get information from multiple tables. But the object model already accounts for relationships between tables. And we saw that the customer class has an orders property, which will contain all of the orders for that customer. And then we saw that the order class has a customer property, which points back to the customer. So the relationships are already accounted for in the object model, so we don't have to do joins. So here's a query to bring back beverages. So we could write the query to link the product class to the category class based on the category ID, or we could write it like this. So here our query is from product in datacontext.products, where product.category.category name equals beverages. The product class has a category property, and that category property references an instance of the category class, and it's an instance that represents that product's category. So product.category.category name is the category name for that product. So for any product where the category is beverages, bring back the product name and the price. Let's go see some additional examples of querying related tables. Let's look at querying related tables, so I'll press D. In our first example, we want to bring back products in the beverages category. So the product class has a category property, and that represents the category that product belongs to. And then we just read the category name from that. So from product in nwindatacontext.products, where product.category.category name is beverages. So we don't have to do the join between products and categories based on the category ID. We just go get the category for that product and look at the category name. And that's going to bring back products in the beverages category and their prices. If we go into the SQL profiler, notice that SQL Server does a join. SQL Server doesn't work on the LINQ query syntax. So the SQL statement that gets generated and sent to SQL Server uses a join, joining products and categories on the category ID column. Okay, in our next example, we want to find customers with 20 or more orders. So from customer in nwindatacontext.customers, where customer.orders.count is greater than or equal to 20. So the customer class has an orders property, which is an entity set or a collection of entities. And the entities are instances of the order class representing that customer's orders. We're going to look at the count of that, and if it's greater than 20, then we're going to bring back the company name and rename it name, and bring back the count of orders and rename that count. And then for each customer, we're going to display the name and the number of orders they've placed for customers that have placed 20 or more orders. Let's go into the profiler, and here's the query. Select company name and then count from orders where that count is greater than 20. So we're not bringing back all of the orders information, just the company name and a number. In our next example, we want customers who have placed 2 or fewer orders. So the first half of this looks the same as the query we just looked at from customer in nwindatacontext.customers, where the count's less than 3. I want to bring back the company name, the city, the region, and I also want to bring back the orders. So now, for each customer, I can display the company name, the city, the region, and the number of orders. And then for each order, in that customer's collection of orders, the order ID, the order date, and the date it was shipped. Now if we look in the profiler, we see there was one SQL statement generated. Bring back the company name, city, region, and then all of the information in the order table for customers where the count is less than 3. So because I asked for the orders in my query, the SQL statement brings back company information and order records. Now because we're looking at customers with 2 or fewer orders, this is the information that came back. But if that query returned 50 customers with an average of 100 orders each, that would have brought back an awful lot of information. So here's a good example of how looking at the SQL profiler or looking at the SQL statement that's generated gives you a good idea of performance. So here we could tweak the query if we needed to bring back less information. So one query bringing back a bunch of information, multiple queries bringing back less information, we can kind of make the call. In our last example, I want the total value of orders placed by a particular customer. So I need to go into the order details table and get price times quantity and sum that for orders placed by this company. So the detail class has an order property which represents the order. The order class has a customer property which represents the customer who placed that order. So detail.order.customer.company_name gives me the company name for each individual detail. So this is a 3-table join, but I can just go from detail to order to customer just by accessing properties. And now for that customer, here's the total value of orders. Again, if we go into the SQL profiler, here's unit price times quantity from details joined on orders, joined on customers for this company.